Hi friends, in this video I will find the inverse of the given matrix by using normal method and the inverse of the matrix by using Gauss Jordan method. Here in intermediate we have learned the inverse. For example, this is the matrix A of order. Let's say here I am writing M cross M. The inverse of this matrix is A inverse is equal to adjoint of A divided by determinant of A. ये हमारा normal method हो गया. So why while nowadays people are using Gauss Jordan method, instead of this A inverse is equal to adjoint of A divided by determinant of A. इसके बजाय ये मेथड क्यों यूज कर रहे हैं आजकल लोग, तो इसका मैं रीजन बताऊंगा. सो दिस मेथड इज कंप्यूटेशनली लेस एक्सप्रेसिव दैन दिस. सो कंप्यूटर साइंस पीपल सेड this statement. If someone asks to the computer scientist, instead of this method to find the inverse of matrix, so why Gauss Jordan method is useful? So they said this method is computationally less expensive than this. So here, for example, I will take here 2 cross 2 matrix, and with the help of this I will show how this method is computationally less expensive than this. For example, if you have let's say here A equal to 2 by 2 matrix. Here I will take this matrix as, let's say A equal to, here I am taking 1 2 and this is 3 and 4. So we have to find the A inverse, means A adjoint of A divided by determinant of A. So first step, try to find the determinant. The determinant of this matrix is, that is 4 minus 6, which is equal to minus 2. So this is the determinant. Now after that we have to find the minor element. So m1 1 means hide the first row and first column. So after that take the determinant of the remaining element. Here I have just 2 cross 2 matrix. This is 4 is the minor of this. So m1 2, just m1 2 means hide first row and second column. This is 3. After that m2 1, so hide first column second row. Here 2. After that m2 2 means I want to find the minor of this, means hide second row and second column. This is simply 1. So these are the minor elements. So you know the formula, the cofactor Cij equal to minus 1 to the power I plus j into mij. This is the formula. So here I will write here. So I don't have place. Cij equal to minus 1 to the power I plus j and mij. So this is the way, this is the formula to find the cofactor element. So from here, can I find C11 as minus 1 to the power 2, 1 plus 1 2, and this is m11. This is minus 1 to the power 2 means 1, simply minus 1 to the power even power plus. So this is simply 4. And this is C12. Now find minus 1 to the power 3, m12, that is minus 1 to the power odd power, that is 3. This is minus 3. So here C21 minus 1 to the power again 3, and m21 is given 2. Here this is minus 2. Here C22, that is minus 1 to the power 4, and m22, this is even power, so it becomes plus. This is simply 1. Now write the cofactor matrix. Here C as, here I am writing C11, C12, C21, C22. So here C is, now tell me, C11 is 4, C12 is minus 3, and C21 is minus 2, and this C22 is here 1, simply 1. Now this is the cofactor matrix. So next step is my find the transpose of this cofactor matrix. Here 4, first row becomes first column. This is minus 3, and this is minus 2, and this is 1. So this is my adjoint. This is my adjoint of A is this matrix. So 4 minus 2 and minus 3 1. So A inverse is equal to adjoint of A divided by determinant of A. So write here minus 1 by 2 times. Here I am writing this matrix 4 minus 2, and this is minus 3 and 1. So here this is simply here this is simply minus 2, this is 1, and this is 3 by 2, and this is minus 1 by 2. this is the A inverse. This is the A inverse of my matrix here A. If this is the inverse, so A inverse, if this matrix is the inverse of this matrix, so A inverse into A should be A. Now check whether this is valid or not. Here I am taking -2, 1, this is 3 by 2, this is -1 by 2, and this is A is 1, 2, 3 and 4. Now here check, here -2, this is +3. First row, first column is this entry. First row means -2 into 1 plus 1 into 3. So -2, this is -4, this is +4. First row, second column is this entry. Now second row, first column is this entry. This is simply 3 by 2 and this is -3 by 2, and here this is now second row, second column is this entry. Now this is simply 3 by 2 into 2 means simply 3, and this is -1 by 2 into here this is -1 by 2 into 4. So how much this is? That is simply -2. So here I will get the matrix as, here -2 plus 3 becomes 1, this -4 plus 4 becomes 0, this is simply plus 1 by 3 by 2 minus 3 by 2 0, and this is 1. So with the help of A inverse is equal to adjoint of A divided by determinant of A, which is equal to, here I am finding the inverse, that is this matrix, and this matrix A inverse, this matrix is the inverse of A matrix. Why? The product of these two, A inverse into A is equal to I. So done. Now I will find the inverse of this same. For example, here I have 2 cross 2 matrix. So here I have 2 cross 2 matrix. Can I write this? I don't have space. I will write here. So here I have 2 cross 2 matrix. This is my 2 cross 2 matrix. For that I need to find here 4 minor element. So after, with the help of this minor element 4, here I am finding the 4 cofactor element and taking the finding one cofactor matrix. After that take the transpose of this cofactor matrix, which is adjoint, and divide adjoint of A divided by determinant of A, that is my inverse. ये मेरा 2 क्रॉस 2 मैट्रिक्स है, इसके लिए मैं 4 माइनर एलिमेंट निकालूंगा। 4 माइनर एलिमेंट के करस्पॉन्डिंग मुझे 4 कोफैक्टर एलिमेंट मिलेंगे। कोफैक्टर एलिमेंट का एक मैं मैट्रिक्स बनाऊंगा, उसको कोफैक्टर मैट्रिक्स बोलते हैं। उस कोफैक्टर मैट्रिक्स का मैं ट्रांसपोज ले रहा हूं, उसी को हम ए एडजेंट ऑफ मैट्रिक्स ए बोलते हैं, एडजेंट ऑफ मैट्रिक्स बोलते हैं। उस ए आफ्टर दैट ए इनवर्स इज इक्वल टू एडजेंट ऑफ ए डिवाइडेड बाय डिटरमिनेंट ऑफ ए मैं निकालूंगा। जो मैट्रिक्स मुझे रिजल्टेंट मैट्रिक्स मिलेगा, ये मेरे मैट्रिक्स का इनवर्स रहेगा। ये हमारा इंटरमीडिएट का मेथड है, जो कि हम यूजुअली यूज करते थे आप तक। अगर मेरा 2 क्रॉस 2 मैट्रिक्स है, तो इस समय मुझे 4 एलिमेंट काउंट करने की जरूरत पड़ रही है। कितने एलिमेंट? 4 माइनर एलिमेंट। ये 4 माइनर एलिमेंट एंड 4 लेट्स से कोफैक्टर एलिमेंट। अगर मेरे पास 3 क्रॉस 3 मैट्रिक्स होती, तो मुझे 9 एलिमेंट काउंट करने की जरूरत होती है। सो दिस इज सेम एज दिस। अगर मैं 4 माइनर एलिमेंट निकाल रहा हूं, तो मुझे 4 कोफैक्टर एलिमेंट भी निकालने पड़ेंगे। अगर मेरे पास 4 क्रॉस 4 मैट्रिक्स होता, तो मुझे 16 एलिमेंट निकालने की जरूरत पड़ती। अगर समझो मुझे 5 क्रॉस 5 मैट्रिक्स मिलता, तो मुझे 25 एलिमेंट निकालना पड़ेगा। अगर ऐसे ही मुझे समझो 10 क्रॉस 10 मैट्रिक्स मिलती, तो मुझे कितने एलिमेंट को माइनर एलिमेंट निकालना पड़ेगा? 100। ये तो हो गया। अगर मुझे ये 2 क्रॉस 2 मैट्रिक्स है, तो मुझे डिटरमिनेंट निकालने के लिए आसान हो रहा है। अगर मेरे पास 10 क्रॉस 10 मैट्रिक्स मिलेगा, तो मैं अगर 10 क्रॉस रो डिटरमिनेंट फाइंड करने का तो मेथड आपको पता है। सो वी हैव टू हाइड दिस एलिमेंट। आफ्टर दैट सो टेक द डिटरमिनेंट ऑफ रिमेनिंग एलिमेंट। अगर मेरे पास 10 क्रॉस 10 मैट्रिक्स है, तो उसका डिटरमिनेंट निकालने के लिए कितना टाइम लगेगा? which is more, that is more time taking, and maybe some calculation mistake, or in computer also there is some error occurs while finding the inverse of matrix by using this as usual method. So instead of that researcher find this method here, Gauss and Jordan. So the simple as I will find the inverse of this matrix by using the same this method. So I will show. So here they use this simple method, I augmented matrix A. उनका ये फंडा है, ये कोई भी, फॉर एग्जांपल here we can take any 2 cross 2 matrix लेट्स से हियर आई एम टेकिंग 2 क्रॉस 2 मैट्रिक्स. इस मैट्रिक्स के ऊपर एलिमेंट्री रो ऑपरेशन फर्स्ट स्टेप में लगाना है. हियर लेट्स से एलिमेंट्री रो ऑपरेशन. अगर इस मैट्रिक्स के ऊपर मैं एलिमेंट्री रो ऑपरेशन इस तरह अप्लाई करूंगा ताकि ये जो मेरा ए मैट्रिक्स है आइडेंटिटी मैट्रिक्स में कन्वर्ट होगा. यहाँ पे जो मैट्रिक्स रहेगा, जो यहाँ पे जो मैट्रिक्स मिल रहा है विच इज करस्पॉन्डिंग टू दिस मैट्रिक्स विच इज द इनवर्स ऑफ माय ओरिजिनल मैट्रिक्स. फॉर एग्जांपल हियर आई एम अप्लाइंग एलिमेंट्री. फॉर एग्जांपल हियर आई एम टेकिंग एनी जनरल मैट्रिक्स which is not identity. I want to find the inverse of this matrix. So I will write this matrix as A is equal to I times A augmented matrix I. So here, if at all, here I am applying the elementary row operations on this matrix. So if at all, here let's say here I got A2 and this is I1. Let's say this is A1 and this is I1. Agar this A1 is equivalent to this A and this I1 is equivalent to this identity matrix. Of course, this is not identity matrix after applying elementary row operation. अगर मेरा ये A1 आइडेंटिटी मैट्रिक्स बन गया मेरे पहले ही एलिमेंट्री रो ऑपरेशन में, तो ये जो मैट्रिक्स मुझे मिल रहा है ये मेरा इनवर्स होगा. अगर नहीं है, अगर A1 मेरा एलिमेंट्री आइडेंटिटी मैट्रिक्स नहीं है तो मैं सेकंड एलिमेंट्री रो ऑपरेशन लगाऊंगा. अगर इस स्टेप में मुझे समझो A2 मिल गया एंड लेट्स से दिस इज A2 मिल गया एंड दिस इज I1 इज कन्वर्टेड इनटू I2. अगर ये मेरा A2 आइडेंटिटी मैट्रिक्स बन गया तो इस समय जो यहाँ पे जो भी मैट्रिक्स मिल रहा है हियर आई विल डिनोट दिस मैट्रिक्स एज I2. ये मेरे मैट्रिक्स का इनवर्स होगा. सो इसी तरह जाना है हमें. सो आई विल सॉल्व दिस सेम एग्जांपल विद द हेल्प ऑफ दिस हियर. सो द वे इज राइट A augmented matrix I. So here A matrix is given 1, 2, 3, 4 and this is 1, 0, 0, 1. Now try to apply elementary operation so that this matrix becomes identity. Here I am applying R2 changes to R2 minus 3 times R1. Here I get the matrix as here 1, 2, here 3 minus 3 times 0, 0, 4 minus 6 that is minus 2. This is 1, 0 as it is. 0 minus 3, this is minus 3 and 1 minus 0, 1. Now here I am applying the second elementary operation as here I want to make this minus 2 as 1. Here I am multiplying minus 1 by 2 to row R2. Then I get the matrix as here 1, 2 as it is. Here 1, 0, here 0 and this is 1 and this is minus 3. Sorry, this is 3 by 2 and this is minus 1 by 2. So here I am multiplying minus 1 by 2 to the row R2. Now I want this 2 as 1. Here I am applying the operation. R1 changes to R1 minus 2 times R2. So plus 2 minus 2 becomes 0. Here I get the matrix 1, 2, 0. Sorry, 1, 0, 0, 1 and here 1 minus, here I am calculating here 1 minus 6 by 2. This is 1 minus 6 by 2 that is minus this is 2 minus 6 by 2, this is minus 4 by 2 that is minus 2, this is minus 2. Now tell me this 0 minus 0 minus minus plus. So here 0 minus 2 into this minus 1 by 2. So minus minus plus and this 2 get cancelled. This is simply 1. Now so this root 2 is as it is. Now this is 3 by 2 and this is minus 1 by 2. Now here this matrix is converted into, here this left matrix is converted into identity matrix and I am giving this matrix as name B. So here this matrix is the inverse of this matrix. So here we can observe one thing. Here within step I got the answer. Here this matrix is the identity inverse of this matrix. But here if you have 2 cross 2 matrix you have to find 4 minor element. If you have 3 cross 3 matrix you have to find 9 element. So here if you have 3 cross 3 matrix also just write A and here write identity matrix of order 3. Try to convert this matrix into identity this side and whatever the matrix here obtained by applying elementary row operation here. So after converting this matrix into I and let's say here B. Here this B matrix is the inverse of your matrix A. this B matrix here, this B matrix is the inverse of A. So here computer science people said this method is less expensive than this. That's why most of the researcher or anywhere they use this method instead of that. Thank you.